In this session, we are going to start our new topic, the Nginx, the Ingress controller, Nginx-based Ingress controller. So in our last session, if I go to my YouTube, just to recall what we had. So here we did last session, we cover NFS storage class setup and the concept of NFS storage classes. So today we have to discuss the detailed concept of ingress controllers. So why we need ingress controller? What is the concept of ingress controller, uh, and what technologies? I mean, what vendors are involved in this ingress controller technology? So actually, so far what we did to expose any application out of the cluster, we use a node pod, for example, this is your cluster, and we spin up some application based on some pod, and we set up some service in front, a cluster IP in front of these service. All pods are connected with this cluster IP, and now then what we did, we exposed this cluster IP just like node pod, and node pod basically did the connectivity of the port that was getting request on cluster IP with the cluster physical IPs, nodes physical IP. All the nodes in the cluster will have that port, and that port range is 3000 up to 32 some range you can see in the documentation. So if you are confused with the node port, just go to our videos that I recorded for the concept of services. So the node port is exported here. Okay. And so node port is actually used to expose any service out of the cluster. But in professional life, this is not the proper way to expose any application to node port. So what we will do, we need to access our application out of the cluster with the port 80 and 443 web-based application. But the we need to place some load balancer out of this cluster, and then we can map this node port with this load balancer, and then an end user can hit to this load balancer to port 80, and you can do the mapping of port 80 with this node port. This will work. You can also expose the port 443 with another service. For example, you set up another service, okay, node port service. This is also connecting on all the pods on port 443. Okay, it will work. And this is connected to as a node port out of the cluster, and load balancer is connecting with your cluster on this node port for 443, and outgoing any user coming out from outside port 443 will be routed here on this map. This will work fine, but think like if you have a number of multiple application you want to expose, how you will do? You will expose multiple node ports, just think like you have another application. Okay, you will set up another node port service, and that node port service is pointing to this pod, and this node port is going on this on your cluster level, and then you will spin up another load balancer in front of this uh, cluster, and that will get the request from the end user. So how many services, how many node port you will export out of the box, out of the cluster, and how many load balancer you will set up, physical load balancer you will set up uh, outside the cluster to route the traffic that is coming on port 80 and then going to inside the pod. So this will increase your cost. I mean, this is very difficult to manage. If you have hundreds of applications, you cannot set up the hundreds of load balancer physically, uh, or in the cloud. You cannot set up multiple load balancer. It will be expensive for you. So the solution is to use a single load balancer and use the ingress controller. So how this ingress controller is working, just think like you have this application, okay, and let me do one thing. You have this application running inside this pod, okay, and you set up a service in front of this pod. Okay, this service is cluster IP and it is connecting with these pods. And now you want to expose these pods out of the cluster. So what you will do, you will set up a reverse proxy. Actually, the ingress controller is working just like a reverse proxy. And how reverse proxy is working, you will deploy some uh, ingress controller, just like traffic, just like Nginx. There are a lot of vendors that are providing you a reverse proxy. HA proxy is from Red Hat, and similarly, uh, mm, there is a HTTP based reverse proxy. So any reverse proxy uh, who will basically perform work on the layer 7. So it will get the request from out of the cluster on port 80 and 443, and it will route to the relevant service. So think like this is your ingress controller, and in this ingress controller, you define if the request is coming for some specific domain, just like if the request is coming from www.example.com, then route this request to this service. Okay, another request for uh, mail, just like I can say mail.example.com is coming. Okay, so just route that request to another service. Just like if I just copy paste again, same thing. Okay, this is another service. It will route here. So it will provide some email service. It will provide you some web service. Similarly, there are different pods running and different services. Cluster IP are in front of your applications, and your reverse proxy ingress controller knows if the request is coming from example.com route to this service. So similarly, your reverse proxy can contain hundreds of thousands of entries for different domain names, and based on those domain names, it can forward the request to those uh, cluster IP, and then cluster IP will route the traffic to relevant pods. So now you did the configuration in your ingress controller. Okay, ingress controller. and Ingress controller knows that which services are attached with which domain name. Now, still your Ingress controller is not exposed out of the box, out of the cluster. So what you will do, you will set up to expose this Ingress controller. You will set up another service in front of this Ingress controller. It will also work like a pod, and you will connect this service in front of this Ingress controller, and you will connect two port. Actually, this Ingress controller will provide you two ports, port 80 and 443. Okay, so whatever request will come on port 80 or 443 for this domain will be routed to relevant service. So this service in front of this Ingress controller is taking care of two ports. And this port, this Ingress, this service is just like a node port. So this node port is connecting out of the box by using two node ports. So this node port, I can say node ports, node port uh, for uh, for 80 and 443. So in fact, there will be some node port IP will be exposed that out of the cluster with some node port. And think like some node port for 80 is just like 3001. And for port HTTPS is 3002. Okay, so just let me map this with port 80 and this will with port 443. Okay, so same thing we did, if you remember, when we exposed the node ports. So we attach some actual running port inside the or on the service level with some node port. So think like a port 80. So this ingress controller will basically use two ports, 80 and 443. So whatever request will come on 3001, it will be routed on port 80 on ingress controller. Whatever request will come on 3002, it will be routed for port 443 on ingress controller. Now, when the request will come, so whatever domain name request came, it will so it will connect the with the relevant service down the with the cluster IPs. So now again, you can say that the problem is same. We have not got the port 80 and 443 out of the cluster. We still are getting the node port. So now we can set up the load balancer, any load balancer. In the cloud, we can take layer 7 or layer 4 load balancer, and we will connect with these two node ports, 3001 and 3002, with this load balancer. In your physical environment, it can be some F5 load balancer, it can be some Fortinet load balancer or Cisco, whatever you can use. And now end user will send the request to this load balancer to port 80 that will be internally connected, be routed to port 80. And when the end user will send request to port 443, it will be connected with this node port. So you will define this port forwarding rule in this load balancer. And when our request will come on 443 on the load balancer, it will be go to 3002, and then it will go to ingress controller. But this request is not coming based on IP. It is coming from domain name. I mean, end user will use the name-based connectivity. So this load balancer contain a public IP. This load balancer public IP. So whatever the public IP you will get with this load balancer, you will make a DNS record in the example.com domain DNS pointing to this public IP. And if you have another service, for example, you set up another application for another customer, and you set up some service cluster IP, and you also add an entry in your Ingress controller that this is my another application, just like www dot newdomain.com. Okay. So think like you have another application that should be reachable on this by this domain name. So now you will also add a rule in your ingress controller to route all the traffic coming for newdomain.com to this cluster IP, and this cluster IP contains a pod attached with as an endpoint. So with this way, only one load balancer out of the cluster can handle multiple domains. And this ingress controller can handle multiple domains running just a cluster IP is set up in front of those applications. So now only one load balancer can can handle multiple domain name requests. So you just need to make a new entry in the newdomain.com DNS with the public IP of this load balancer, and when the request will come on port 80N443, it will be routed to Ingress controller, and when Ingress controller knows that this request came on this IP, but for this domain, then it will be routed to this service only. So this is the whole way the flow of your traffic that will be used to connect with your ingress controller, and the configurations we will provide to ingress controller to perform this service-based routing decision. So I hope you got the idea how this is working. So the previous example I gave you, that was the problem was we can use the node port for every application we created, but we need a dedicated load balancer for every node port for every application. So now let's start some practical about this ingress controller. So the concept of ingress controller is same. This ingress controller can be from different vendor. So the most used ingress controller in our practical life is Nginx based ingress controller. So if I go to this documentation docs.nginx.com, so it will give you a lot of information about this Nginx project. So this Nginx project is providing uh, multiple applications. Web application firewall, it is providing it is DDoS protection, Nginx management suite. Okay, but we are interested in Nginx Ingress controller. So I will click on Nginx Ingress controller. So this is the complete documentation open for the Nginx Ingress controller, tutorials, troubleshooting, everything you can read, overview. But I am interested in the installation, and installation can be with different methods. Here is the way to build the new image for the ingress controller. Multiple ingress controller we run, but we just want to install Nginx Ingress controller. We can deploy with Helm, we can deploy as in ingress operator. So far we have not discussed these topics. So I will show you installation with the manifest. So installation with the manifest, actually this Nginx is an open source project, as well as you can take the support, the paid solution subscription of Nginx Ingress controller. So when you are working straightforward with the free version of Nginx Ingress controller, you can use its freely available online Ingress image for its container that will run inside the pod. But there is another Nginx Plus Ingress controller. It is a subscription-based model. I mean, you can say you have two options for this. Both require Nginx Ingress controller subscription. So for this image, you cannot get free of cost. It is not available when you will get the subscription. So after getting the subscription, you can download the image using your Nginx Ingress controller subscription certificate and key. They will provide you some certificate and key, and you can read this whole documentation to pull down that specific image provided for your subscription. So when you will get the subscription, they will guide you the complete I mean, with the documentation how you can build this image. But today we are going to use this one. You can also use this Nginx Plus advanced level of Nginx controller with, I believe they are giving some 1 month free subscription. So you can generate some 1 month free subscription certificate and keys, and then you can build your own image and use your Nginx Ingress controller JWT token to get the image. So there are two methods you can generate the Nginx Plus image. So this is not the part of our today's discussion, that how to build this Nginx Plus Ingress controller. So we will go ahead with this one. Build your own image. We can also build our own image, but I will follow the documentation with the pre-built image, the free edition. The Nginx Plus is providing us the advanced level of security. Some basic level of security is also available in open source variant. But if you are working in enterprise environment and you want to protect your environment with this Ingress controller for a lot of security concerns, you can configure it to with some advanced level of configurations. So clone the Nginx Ingress controller repository using the command shown below. Replace the number variant number. So here, this is the Git repository available online. You can browse this and you can see which variants are available. And if I, for example, if you want to go, so right now, the most stable variant is this one, variant 3.61. If I just browse this repo, repositories, Ingress, Kubernetes Ingress. Here you can see these are all the branches, and different variants are available for this Ingress controller. But I will use this method straightforward provided here. So I will pull down this variant, this branch variant. This is the name of the branch. So I am on my master node, and here me just clear what I downloaded earlier. You need to install the Git client before running this command. So it is cloning the whole repository. And all the manifests are downloaded here. And here you can see the Kubernetes Ingress directory is created. Now, if I go under this Kubernetes Ingress directory, there are a lot of manifests available under different directories. So I will follow this documentation. So I have to go under this directory, app protect DDoS. To use app protect DDoS, install the app protect DDoS attributes using the attributor using the provided manifest in the same namespace as Nginx Ingress controller. This basic variant will provide you DDoS protection too. We can use this feature too if we want to enable. So set up the role-based access control. You know, the role-based access control is required with some service account that will perform a lot of API-based requests and configurations on our behalf. I mean, whatever we will request to do this name-based decision to different service. So that configuration will be embedded into this Ingress controller configuration by some service account. So here, this is the manifest. If I show you under deployment or common, there is NS and SA. If I just show you this manifest, so you can see they are creating a namespace with Nginx Ingress, and they are creating a service account. So we need to apply this to create these resources. So Nginx Ingress namespace created, and get a service account in Nginx Ingress namespace. You can see the Nginx Ingress service account was also created. So this account will perform a lot of activities to configure the Ingress controller configuration files. Now we apply, okay, second thing is create a cluster role and binding. So, you know, we discussed this in detail. So there are some cluster level of role, and under the deployment, there is a file. This file, if I show you this file, you can see this file contains under the metadata, this one namespace where they defined I think this resource they are creating. Yes, cluster level flow role. That's why no namespace is defined. And on the cluster level, you can see what resources role-based access controller created. There are different level of resources available. So API groups, apps level of API groups. Okay, so we did this in detail in our role-based access control. You can follow those videos. So just these different resources: get, list, watch, update, create, delete. The resource rights are given to this new cluster role, and the name of this cluster role is Nginx Ingress. Okay, and the second thing is the binding of this cluster role created with the service account Nginx Ingress. So service account is also Nginx Ingress, And the cluster role binding name is also Nginx Ingress, and the cluster role is also Nginx Ingress. If I do kubectl get cluster role Nginx, so you can see Nginx Ingress cluster role created, and cluster role binding, it's the same name. So this service account contains this role. So now this service account can perform some activities based on this role, cluster level role. Okay, now the next thing is we create a service account, and we give that service account some rights on the cluster. Now, if you are planning Nginx App Protect or Nginx App Protect DDoS, additional roles and bindings are needed. If you want to secure your application from DOS attacks, and then you need to configure some additional settings. So for that reason, you need to create App Protect role-based access control and App DOS role-based access control. It will give the additional rights to this service account to perform additional level of task on your cluster. But I am going to skip this part. We just want to understand how the basic Nginx controller is running. We just want to make Nginx controller uh, uh, to route some domain name based request on some specific service cluster IP. Okay, so I am skipping this, but you can follow this documentation, and you can see how this can help you in your professional life. So create common resources. In this section, you will create resources that most Nginx Ingress controller installation require. Okay, optional. This is optional, but as it is written here, you will create resources that most Ingress Nginx controller installation required. I mean, this is optional, but it is important to create. Here, they are creating a built-in, they create a secret. I will show you this manifest. And if you remember, when we did the session for secrets, so I gave you the idea of two type of secrets. So third type of secrets I told you in that video, I will give you in Ingress controller. So this is the third type of secret. So actually this is a manifest, and this secret contain the public and private certificate. If I just run a command kubectl create secret --help. So we did a Docker registry related secret, we did a generic related secret, but we skipped the TLS based secret. So TLS based secret, if I show you, create secret, for example, my TLS, okay, and TLS -help. So, sorry, I think TLS based secret, then I can provide the name of secret, then I will provide the certificate that I purchased for my domain. Okay, generated or signed certificate. I can use self-signed certificate too, then you will get the error on the page. So I have to provide this secret, these two file information, the public and private key. So that will be saved in your secret with base 64 encoded information. So here what they did, they provide you some generic self-signed certificate, and you can use this when you will do an offloading of SSL certificate on your Ingress controller. So Ingress controller is also working for SSL offloading. I mean, when the request will come on port 443, so this Ingress controller contains the TLS certificates information in the form of secrets, and it will use those secrets to get those certificate information. And here the SSL will be offloaded. All the connection from end user to Nginx controller will be encrypted, and the remaining connectivity to cluster IP and pod will be open. Within the cluster, it will not be secure, but end-to-end connectivity till Ingress controller will be protected by TLS certificate. So Ingress controller is also doing the offloading of SSL. So if I go to this documentation further, so I am not going to create this resource. I will show you how to create my own certificate. I will create my own certificate, or I can use this certificate too, but I am just skipping this part right now. Create the config map to customize your Nginx setting. This is some config map. Let me check what this config map is doing. So this config map is empty. There is no data under this config map. So I believe this need to create, I believe this need to create uh, for for the purpose of some configuration required by this ingress controller. This is some empty config map. Maybe it will be used by this ingress controller somewhere. Maybe it will put some data in this config map. So far it's empty. I just created because it's written in the documentation, and create the ingress class resource. Nginx ingress controller would not start without an ingress class resource. So just like we did our storage class, similarly we have ingress class. The concept is same. I mean, the storage class was referring to different storage technologies, just like block storage or cloud object storage or S3 or NFS based storage, whatever storage we can provision to the cluster. Similarly, we can have multiple ingress classes in our cluster, and we can deploy multiple ingress controller in our cluster. So for example, I deploy one ingress controller of Nginx, another ingress controller of traffic, another ingress controller third with some other vendor, HA proxy or HTTP based. So each will have its own ingress class, and each ingress class will refer to that specific ingress controller. So all ingress controllers will expose their own node port out of the cluster. Okay, so this diagram that I explained you is just making a connectivity because we have one ingress controller. So same another ingress controller I can have that will expose the node port, and then I will place its own load balancer in front of that ingress controller. But this is very rare. You will set up multiple ingress controller of different vendors within the same cluster. But this is technically possible. You can do this. So that's why these two ingress class, and ingress class is a resource, API resource of cluster level. So this ingress class is created. If I show you this file manifest, so you can see its kind ingress class. Its name is Nginx. Okay, and its controller is Nginx or org ingress controller. So it is pointing to deployment. Yeah, it is pointing to this ingress controller. But one thing yeah, here we did just a config map. Okay, so far we have not done the deployment. So this is the ingress class, and if I show you kubectl get ingress class, So this Nginx Ingress class is created that is pointing to this controller. And that controller will be Nginx based. And this is the reference, you can say the reference will be pointing to Nginx Ingress controller. Okay, so now we create the class too. If you want to make the Nginx Ingress controller interface your cluster default, okay, so default ingress class, we can also create. What is the purpose of default ingress class? I will explain you. Create custom resource. Okay, to make sure that the class is ready, you will need to create custom resource, define custom resource definition for various components. So custom resource definition, other than provided by the default API resources in the Kubernetes cluster, we will provision some additional API resources to manage the ingress controller, and those API resources we can use to manage the ingress controller. It will be we will not manage it. Actually, ingress controller will use those resources to perform the configurational changes. So there are two ways you can install the custom resource. Alternatively, you can disable the requirement by setting enable custom resource command line argument to false. We have not done this, or we can do this, but we will deploy these custom resources. It is good to deploy these resources because to make your ingress controller, Nginx ingress controller, uh, function properly. So either I can apply by the YML files, or I can use the by cloning the repo. So YML files, let me check what is the difference. Uh, Install cards after cloning the repo. Okay, so yes, it is. This will be good idea. So actually, under the config directory, custom resource definition base, these manifests are available under the config directory. So I can directly apply these all at once. So actually, I am inside the same directory, Kubernetes Ingress. And here you can see this config, and card, everything is available under this directory. So if I show you this now kubectl API resources, so you can see that a lot of these new resources are created with some name of ingress. Here will be the name of the, you can see ingresses, ingress class. So these are created, no, this is the API level. The virtual server routes, the virtual server, transport server, these are created by this these manifest we created. Okay, so next, so this is the dependency. Install code from YML, okay, from repo, and both are for the same. Okay, next, core custom resource definition. Create custom resource definition, or we can create by this single manifest. What either you use this way or this way, both are same. It will create the same. It will go to get this Git repo online and apply from the Git repo. But we use the cloned repo to create these resources. So you don't need to run this one. Okay, next thing is custom resource definition. For the Nginx app protect web application firewall module, create custom resource definition for app policy, app log conf, and app user sig. So we don't want to use the Nginx for web application firewall. And I believe web application firewall will only work if you are going with Nginx Plus. With simple Nginx, it will not give you. So that's why it's an optional. I am skipping these 1 and 2 step. Okay. Now all the baseline requirements are done. We have our namespace, we have our service account, we have role-based access controls for the service account, we create the custom resources, and we create the ingress class. Now, this part is not done so far, this box. If I highlight this one, this part that will do all the magic of routing the name based to different services within this cluster. So this will run as a part. And whenever we want to make auto healing in the cluster, we can deploy something like in the form of deployment, so that if pod is deleted, it will automatically be auto heal recreated. And or we can deploy with the daemon set. I mean, on each worker node a pod will run. So you have two options to deploy Nginx Ingress controller, either by the deployment or by using daemon set. Same thing I explained you. So with the deployment, we can provision and it will make different pods in different worker nodes over the cluster. But daemon set will make sure every worker node has a pod. So there is no hard and fast rule. Either you can use deployment or daemon set. Before you start, update the command line argument for the Nginx Ingress controller container in the relevant manifest file to meet your specific requirement. Okay, use the deployment or use the daemon set. So I will go ahead with the deployment. So I am just going to copy and paste this one here. It will make a deployment, and let me explain you this deployment. Name ingress controller. This deployment is a simple deployment we learned. It has one replica, and you can see the service account. So all the power is going via this service account that can perform different activities on our cluster that we created. And security context we will discuss in detail when we will do the Kubernetes security topics. Here you can see this image was pulled down that was available on the Docker Hub, and it is using it. This container will expose two ports, port 80 and 443. Okay, these ports are based on readiness, and this is for the Prometheus purpose, but we can skip these ports too. But these two ports are very important because this is a reverse proxy and it can do the reverse proxy based on port 80 and 443. Whatever request will come on port 80, it will do something. Whatever request will come on port 443, it will perform something. And we will create a service in front of node port service in front of this deployment that will make these two ports out of the cluster like this. Let me go down. We can see the resource limit is given there 100 because this is just a reverse proxy. It will not take too much CPU and RAM. So one pod will this amount of CPU RAM, and environment variable is given here. The pod name. These are some environment variable for its internal configuration. And if we go down, this is the configuration file path inside this pod. Yeah, external service Nginx Ingress that will take care of this pod to get the request. And okay, so this deployment is done. Okay. So now if I do a kubectl get deploy ply-n, what was the namespace? In the namespace, this namespace, okay. So here this is ready. If I look some pod, yes, pod is ready in this namespace and it is up and running. It's mean this is this engine is now up. Now I use this method for Nginx Plus. If you have different image, you can use this manifest. And if I show you this manifest, just for your information, this manifest is same, but the difference is only the image name is Nginx Plus. So you can provide here the complete repository name where you push your image after building your Nginx Plus image, after getting your subscription. Okay. Now, to use as a daemon set, we can use this daemon set. Okay, we will not use this. One method we have to apply. Confirm Nginx Ingress controller is running. I showed you this same command in this namespace. This pod is running. Now, how to access Nginx Ingress controller? This way, I mean these lines going to out of the cluster. So we need to create a service in front of this controller, and that service will be of type node port. So here, using the deployment, if we did the deployment, your type of ingress controller, you have two options to access Nginx Ingress controller. Create a node port service, create a load balancer service. So you remember in our service video I uploaded in this channel, load balancer will automatically create a load balancer in out of the cluster in the cloud environment. But a layer 4 or layer 7 type of load balancer, we will discuss this in detail when we will deploy this Kubernetes cluster on some cloud. But I will not use the load balancer type of service because I'm not working in the cloud. I'm working on-prem. And if you are working on-prem, so use node port. It will just give you the node ports. Rest of configuration of load balancer in your physical environment is not the responsibility of this cluster. But in cloud, it's the responsibility of this cluster to provision this external load balancer. So node port we will use. We just need node port. Rest of all we will do manually. So here I will apply this node port. If I show you this manifest, this is very interesting. It is under this namespace. It is creating node port and it is port 80. Port 80 I showed you in the deployment configuration, and port 443. So these are the two ports that will come to this service and type of node port, and it will connect with selector Nginx Ingress. This is the selector of our deployment. If I show you this deployment, this one. So here the selector, app Nginx Ingress. So same selector they defined here. So it will automatically attach with that deployment. So these are the concepts related to services. You can see in the services videos. So node port will be created. Now some node port will be created to reach to port 80 and 443. So I applied this. And here if I show you kubectl get svc -n this Nginx Ingress. So you can see the node port type of service created. This is a cluster IP, and this port out of the cluster can reach to port 80 on Nginx Ingress controller, and this port out of the cluster can reach to port 443 on my Ingress controller. If I just do a telnet for the verification to on my worker node or master node on port 30412, it is reachable. It's mean my node port is working. The second port I will telnet 32733. This is also reachable. Now I will do just a test. What page it will show me if I send an IP-based request to my master node or worker node on this port. It is saying bad request. I mean, it will only accept the request based on name. It's a reverse proxy. And if I send a request on 327733, not found. So this is HTTP request. Second was bad request because it was HTTPS. And so far our Nginx reverse proxy is empty. Its configuration is, it does not contain any configuration. Sorry, I wrote the wrong. HTTPS. The site cannot be reached because I have not provided any SSL certificate to this yellow box. Okay, so that's why HTTPS request it is not receiving. But port 80 base request it is receiving, but giving me error that I cannot show you anything because you have not configured me. So whatever request it's coming to you, it is just discarding because there is nothing configured yet. But our engine is up. If we are getting these pages, it means our engine is running perfectly fine. The second port, just again, I will verify 32773, and with the telnet, I also validate. Not fine, Nginx. It's a reply from Nginx, mean this part we ran is responding us out of the cluster. So we have done this part, and the documentation is saying we have created this node port, and AWS user follow the additional steps to work with Elastic Load Balancer TCP. So this we will discuss in the cloud-based deployment, but this is on-prem. If we use a daemon set, then we have to use connect the port 80 and 443 using the IP addresses of any node. So daemon set, for the daemon set, we don't need to create this node port. daemon set will directly create port 80 and 443 connectivity. It will not use uh, the node port based connectivity. This is some different concept, but you just follow the deployment based because you better know about the concept of node port. Now uninstalling, this is uninstallation process. We don't want to uninstall. So far in this video, what we did, we set up this one, this part. We set up our node port. This one, we set up these node ports, this node port service, and we set up all the associated resources required to deploy this ingress controller. Now our ingress controller is up and running, but the missing part is we have to now configure it, and we have to run some real life application that will be routed by this ingress controller. So in this session we are doing to only to this level. In next session, in next video, I will show you how we can put the configuration inside this ingress controller, and we will throw some name based request on these node ports, and it will send to relevant application. So that part is known as ingress. So for that reason, we will use kubectl API resources grab ingress. So you can see ingress is we have to set up this. We set up ingress class. So then we will set up ingress. So ingress will define the rules that will be put in the configuration file of the controller. So this will the part of our second video.